Welcome, join the 5G Advanced course. I'm Felix. Today's topic is 5G network architecture and key technologies. In this course, we will review 5G key capabilities and then discuss about the change of 5G network. No matter in 2G, 3G, 4G, and 5G, end-to-end network includes three parts: the access network, barrier network, and the core network from low to high. The logical structure is similar, but what's different between 5G and other generations? And what's the key technology in 5G? Let's see them together. In Chapter 1, let's review 5G capability. The ITU defined the three biggest application scenarios of 5G, which are eMBB, Enhanced Mobile Broadband, URLLC, ultra-reliable and low-latency communication, and MMTC, Massive Machine Type Communication. eMBB, the target is 10 gigabit per second downlink data rate for single user theoretically. But today's commercial network cannot reach it. And next one, URLLC. The end-to-end latency is 1 millisecond. Low latency refers to fast response and the short transmission time of content over the network. Not only low latency, also the 99.999% reliability. And next one, MMTC. The target is 1 million connection per square kilometer. The unit is density. It's different with other generations. In 2G, 3G, and 4G, when we evaluate network performance, always based on cell or single base station, the unit is cell or site. But the unit is density in 5G, and you can try to consider why the unit is changed in 5G. And you can find the answer in this course. ITU also defined the requirements of 5G network from 8 perspectives. Let's see the comparison between RMT 2020 and the RMT Advanced. What's the meaning of the RMT 2020? This is the official name of 5G. RMT Advanced is LTE Advanced Pro. The peak rate, latency, and the connection density we just mentioned. And let's see the user experience rate first. That means as long as you connect with 5G network, the network should guarantee that it can provide at least 100 megabit per second data rate for you. This is the minimum requirement of some 5G services. And next one, spectral efficiency, 3 times higher than LTE Advanced Pro. How can 5G meet them? There are 3 typical technologies: new channel coding, high order modulation, and the massive MIMO. And we will talk about the 3 technologies later. And next one, mobility. 5G can support 500 km per hour, and 4G can support 350 km per hour. And this target, this value, focus on ground transportation. And next one, the network power consumption efficiency is 100 times higher than 4G. And the 10 megabit per second square meter regional traffic capability also use density as the unit. So you can see in 5G, when we evaluate the network performance, we always based on density. Why? Because the cell border is not as clear as before. And the detailed reason you can find in this course. Until now, we know the network target of 5G, and all of the performance are higher than 4G. But how can 5G meet them? Something must be developed and something must be new. This course will focus on 2 topics: new architecture and new air interface. New architecture guarantees the possibility of network slicing deployment and further achieves high reliability. Air interface, the interface between the user and the base station. New air interface improves 5G performance from 4 dimensions. Let's see the next chapter for more details. In the second chapter, let's see the new architecture first. Non-standalone solution, just like the left figure. 5G rely on 4G. Without a 4G base station, 5G cannot work. Now, there is one question. Can you distinguish which option this figure belongs to? Give you 3 seconds. Yes, option 3X. With the 4G core network and the continuous 5G coverage, we can deploy a standalone solution, which 5G is independent, just like the red figure. For 5G network evolution, the final solution is standalone and will support all of the 5G application scenarios. Standalone solution is a mature network include NG-RAN and NGC. NG-RAN is short for Next Generation Radio Access Network and consists of 5G base station or G0B and base stations through the following interfaces to communicate with each other network elements. XN is the interface between base stations, and UU is the air interface. Between the NG-RAN and NGC, the interfaces are NGC for control plane and NGU for user plane. And NGC is short for Next Generation Core, includes several network functions, just like the access and the mobility management function, or AMF, and the user plane function, or UPF. There is one key difference with 4G. This is a core network element. In 4G, the core network elements are all hardware entities, but the 5G core network just functions, which are realized by software only. This is 5G core network cloudification. Not only 5G core network, the entire 5G network is cloud-based. There are many new services and applications that will be realized in 5G and further realize the digital world. 5G network is not only just an end-to-end pipe, but a unified platform which can support all access modes and all services. The core network of this platform is called SOC, Service-Oriented Core Network. There are 4 features of SOC: CUPS, control and user plane separation. For different scenarios, we can deploy the control function and the application server at the different data center. Control plane is centralized, but the user plane can be distributed. It's different with 4G, that the control plane and the user plane are all centralized. SBA, Service-Based Architecture. It means the network structure is not fixed in the future. It can be changed by demand. If one network is specific for a kind of service, it could be physical or logical network. That is network slicing. And you see, all features need the same foundation. That is native cloud. It can help carrier build robust, effective, elastic, and agile core networks to quickly meet and match different network application scenarios and differentiated service requirements. In order to have a better understanding of CUPS and the slicing features, let's move on to the next page. Before we talk about CUPS, let's think one lesson: the online shopping. When we want to buy something online, we search it on the website and order it online. And then we just waiting for the delivery man send the goods for us. Maybe one day, maybe several hours. What does the waiting time depends on? Depends on the distance between the warehouse and our home. The closer the warehouse is, the shorter the time is. Online shopping, just like we requested the service through the network. The order is control information carried by control plane. The goods is service data carried by the user plane. In the traditional generations, like the left figure, control plane and the user plane are all centralized at the top of the network. If you want to download something, you should send a request first and then receive the data from the top servers and you should go through 3 layers with long time delay. But 5G is developed just like the red figure. At a different layer, we can deploy different data center. Control plane function can be deployed at the central DC, and the user plane function and the application server can be deployed at a local DC or edge DC. This is centralized CP and the distributed UP. The centralized control plane helps simplify operations and maintenance, and improves operations and maintenance efficiency, and also accelerates the deployment of new services. The position of the user plane mainly considers the service delay requirement. For example, the Internet of Vehicle. The user plane should deploy close to the user. The shorter latency can improve user experience, and also closer server can saving bandwidth between the local DC and the central DC. CUPS need integrate mobile edge computing or MEC server, and deploy MEC at edge DC or local DC. And there are 7 MEC deployment scenarios defined by European Telecommunications Standards Institute, or ETSI, and divided into 3 categories, corresponding to 3 requirements respectively. Number 1, application localization, is for more security reason. For some information which is very sensitive of security, it's not suitable to go through the public network, so enterprise can store information in the edge server. No need to go through the entire network. That can reduce the potential risk of information leakage. What's the requirement of this scenario? More security. And next 2 scenarios are content regionalization and edge computing, used for video system and the Internet of Vehicle, etc. And what's the requirements of these 2 kinds of scenarios? And you can try to consider. Yes, number 2 for saving bandwidth, and number 3 for lower latency. But how to ensure that the advantages are available to users? That is, how to improve the reliability of service. The solution is network slicing. This concept is very important in 5G. And the purpose of adopting network slicing technology is to improve the reliability of data transmission. That means the delay of data transmission is definable, small fluctuation and less error. The solution of traditional network is to provide private network for industry user based on hardware isolation, but the cost is high and the utilization is low. So 5G proposed the network slicing technology. What's network slicing? Slicing is the division of a physical network into logical network through software function. Like this picture, cut the whole bread into pieces. But if you want to understand this concept better, there is another example. The computer hard disk. For example, I bought one laptop, and the hard disk resource is 500 gig. I install one operation system, and then I separate the hard disk into drive C and drive D, 250 gig respectively. If the drive C is full, it doesn't affect the drive D because they are isolated from each other. And this isolation is achieved by software function. If I take the hard disk out, it's still one physical entity. Slicing, just like the disk partition. A slice management software is used to slice the end-to-end network. And each logical network corresponds to a set of resources. For example, the core network corresponds to storage and computing resources. The barrel network is a transmission resource, and the access network is the radio resource. And each logical network is isolated and dedicated. What's the advantage? And you can try to think. What's the advantage of the logical network isolated and dedicated? There is one example. When industrial user and the public user use the same base station, some of the base station resources already isolated for the industrial user. Even the network consumption of public users, the use of base station resources by industrial user will not be affected. So the service of industrial user is guaranteed, just like we drive from city A to the city B. If we drive on the isolated road, there is no influence from other cars, so our arrival time is fixed and predictable. This is reliability. But the traditional network cannot support it, just like the up figure. Because 2G, 3G, and 4G are shared network. Okay, pay attention, a shared network. What's the meaning? All of the services share the same network and the same set of resources. If one service takes up a lot of resources, it will definitely affect other businesses. If network resources are limited, no matter how high your priority is, the network cannot guarantee your experience, just like the first figure. Why 5G need network slicing? Because 5G is mainly aimed at the industry services. Industry services have high requirement for reliability and need occupied resources rather than share them. The disadvantage of traditional resource occupation solution is high cost and long deployment period. And now, one physical network divided into several dedicated logical pipes for industry, which is flexible and good cost effective. Based on network slicing, operators have more opportunities to enter the huge vertical market. Please note that the network slicing is an end-to-end technology. So the core network needs slicing, barrel network needs slicing, access network also. So how does core network do the network slicing? As we know, 5G core network based on cloud. All of the functions are programmable. There is a core network programmable function site. This site separated into user plan and control plan with different specific functions respectively. According to different business requirements, operator can select specific functions and compose one slice. For example, Internet of Vehicle or IOV slicing and smart meter reading slicing. IOV scenario is delay sensitive and high reliability requirement. So in this slice, the user plan deploy reliable function and vehicle to everything or V2X server at HDC, which is close to user. And the control plan select mobile management function. But the smart meter reading scenario is different. As we know, that meter cannot move, so no need mobile management function. And this scenario isn't delay sensitive, so HDC and local DC no need to deploy functions. Combine different functions for different services. This is the way of core network slicing. How about barrel network slicing? In barrel network, flexible Ethernet is used as a core to construct pipes. As flexible Ethernet is a time division multiplexing or TDM system. Services can be isolated by time slot, and end-to-end hard pipe slicing can be implemented. One hard pipe slicing corresponds to the same types of services or similar requirements. In each slice, different users can be isolated using the current VPN and the QoS, is short for quality of service mechanisms, to class different user level. At the management and control layers, each segment has its own view and resource allocation. This is the way of barrel network slicing. How about radio access network? For example, radio access network can be based on radio resource isolation. But before we discuss that in detail, let's see the new architecture of 5G radio access network. The evolution of radio access network, or RAN, is from DRAN to CRAN to Cloud RAN. The DRAN is short for Distributed Radio Access Network, and the CRAN is short for Centralized Radio Access Network. Let's see the DRAN first. The DRAN, the BBU, or baseband unit, and the RU, or remote radio unit, are deployed at the base station site and using fiber connect with BBU and RU together. Disadvantage of DRAN is difficult to manage a lot of distributed BBU. Operations and maintenance cost is high. So the network architecture updated to CRAN, centralized BBU deployment. In the CRAN, all base station, centralized BBU deployment. At the base station side only has RU and antenna. If the engineers want to manage the BBU, they only need to go to the central equipment room. That can save the investment, and another benefit is a better coordination inter-base stations. But the DRAN and the CRAN are all hardware-based, cannot meet the cloud requirement, so 5G updated to Cloud RAN. Cloud RAN divides base station functions into two parts. One is central unit, or CU, which processes non-real-time signaling, such as inter-base station handover. And another one is distributed unit, or DU, which focuses on the real-time processing, such as power control and scheduling. One central unit can control several distributed units, just like one brain of the distributed units. Central unit is the software and need to be deployed at the server. Distributed unit is hardware-based. And there are two options to deploy central unit. The option 1 deploys central unit at the data center for higher control processing and manage more distributed units. Option 2 deploys the central unit at central equipment room for shorter latency, but will sacrifice the management number of distributed units. The border of cell is not clear as before. So when we evaluate 5G network performance, it will be based on density rather than cell or site.